So many different types of diode. Each one has its own unique abilities. This particular video is about PN junction diode. A diode is like a one-way valve which allows the flow of current in one direction and blocks the flow of current in opposite direction. The construction and working of a diode is based upon semiconductor and their properties. Before understanding a diode, we must have to first understand what are semiconductors. On the basis of conductivity, materials are broadly classified as conductors, insulators, and semiconductor. Conductors like copper has a very high electric conductivity and a very low electric resistivity. On the other hand, insulator like plastic has a very low electric conductivity and a very high electric resistivity. The electric conductivity of semiconductors lies in between the conductors and insulators. Some of the most commonly used semiconductors are silicon and germanium. Let's understand the conducting behavior of semiconductors with the example of silicon. Silicon is the second most abundant element in the Earth crust. In silicon, each silicon atom has 4 valence electrons. Silicon form covalent bond by equal sharing of its valence electrons with neighboring 4 silicon atoms. Due to this, pure silicon does not have free electrons. As a result, pure silicon is a very poor conductor of electricity at normal temperature. Although the conductivity of semiconductors or silicon can be improved by using a technique known as doping. Doping is the process of adding suitable impurities in a pure semiconductor. Impurities are classified as a trivalent and a pentavalent impurity. A trivalent impurity, like boron, has only 3 electrons in its valence shell. On the other hand, a pentavalent impurity, like phosphorus, has 5 electrons in its valence shell. Because of this, when a trivalent impurity is added in pure silicon, a vacant position of electron, known as hole, is left. This type of semiconductor is known as a p-type semiconductor. And when a pure semiconductor doped with pentavalent impurity, a free electron is left. This type of semiconductor is known as an n-type semiconductor. Due to the presence of free electrons and holes, doped semiconductors have good electric conductivity. Now, let's see how p and n-type semiconductors used to construct a diode. To form a PN junction diode, a single piece of pure semiconductor is half doped with a trivalent impurity, and another half is doped with a pentavalent impurity. As a result, half of the material become a p-type semiconductor, and another half become n-type semiconductor. Let's see what happens in a diode at atomic level. The free electrons from the n side naturally migrate to fill the holes of p side. Because of this, the boundary of p-type semiconductor becomes slightly negatively charged, and the boundary of n-type semiconductor becomes slightly positively charged. This induced potential is called barrier potential of diode, and this region is known as depletion region. Barrier potential prevents the further natural migration of holes and electrons, and that's how a diode is born. A diode can be connected in a circuit in 2 different ways, either in forward biasing or in reverse biasing. In reverse biasing of diode, the positive terminal of battery is connected to N side, and the negative terminal is connected to P side of diode. As a result, holes attract towards the negative terminal and electrons towards the positive terminal. In this case, flow of current is not possible. That's why a diode does not allow the flow of current through itself in its reverse biasing. But in forward biasing, polarity of battery is reversed. Now P side is connected to positive terminal and N side to negative terminal. In this case, current flow easily through the diode. The variation of voltage and current for a diode is described by its VI characteristics. In forward biasing, diodes start conducting when applied voltage becomes greater than its potential barrier. In reverse biasing, a constant amount of current flows, which does not depend upon applied voltage. But if we keep increasing reverse voltage, breakdown of diode occur and amount of current rise suddenly. If you find it helpful, please like the video and subscribe my channel.